Hello, my dear student. This is week 4. Hope all of you are in well situation. In this week, we do the experiment of study of mathematical operation using OPAMP as an integrator and differentiator. In your theory course, you will learn the theory of an integrator and differentiator. Mm, and you will learn also the theory. Uh, This is a integrator circuit and this differentiator circuit. For experimental setup, these two circuit we use, but the value I will take another value for better this resistor and this capacitor. I will take another value for better output in the simulation diagram, because in real real life experiment and the simulation experiment is a little bit different. That's why we need to take another uh, value of this capacitor and resistor. And before starting, I want to told you another things. Why this student open another discussion? In previous, I told please don't open another discussion, but you don't follow my instruction. You open another discussion and comment share. I told you be careful. It is very difficult for me to give the number. You see, this is the right way. 60 student is in the right way. They just open in my discussion, see the question and replay here. This is the right procedure. This is the right procedure. But all of you are open and new discussion. This is very difficult to give the mark. I need to open everyone and give the mark. It is difficult. So please ignore this one. From this is the last warning. If you again do this, I will not give you any mark in the forum. And in this week, I have no, I don't give any forum for another reason. No, so please don't tense about this. Why we don't give, um, I don't give any forum in this week. So this week have no forum. Go to the experiment. This is integrator and this is differentiator circuit. So we will do the simulation on the Proteus software. Open the Proteus, new project. Next, create a symmetric from. Next. We need how many equipment? Now this is open capacitor resistor. This is AC voltage source. So I need open 7 for 1. I need resistance. Need capacitor. Uh, for biasing we need cell. Resistor. One AC source. B. These 5 things we need for experiment. So take the open first. Now for integrator circuit. First we do the integrator circuit. Terminal is grounded. So make plus terminal is grounded. Ground, take the ground, make the positive terminal grounded, and negative terminal is connected with the resistor and AC source. So we have to take a resistor in the negative terminal and an AC source. Then in this terminal. We have to give output resistance. To give the biasing of this OPAMP, the cell meter cell meter connect with terminal 7. This terminal will connect with terminal 4. Need to make all terminal grounded. Grounded. Terminal also grounded. Terminal 2 and the output. This is the complete circuit. We need to change the value, and it should be for better plot. You take this 5 frequency, and this is 1K. Take 1K. Oh, we are missing another one. This capacitor. Capacitor connected to the minus terminal and the output. We need to connect the capacitor to the minus terminal and the output. Here and connect output and the minus value. You take you need to take the capacitor 5.8 5.8 micro, sorry, 5.8 micro. Take the plot, take the probe in the output input address. First B1, this is input, address, output. Just run. Oh, sorry, we need to give the biasing voltage 12 volt. So just run, stop, and this is the integral circuit output diagram. How this is come in your theory course, you will learn this. And yeah, this is integrator. For report, you have to write the theory and this diagram, and then you have to give the this diagram and also this diagram. For this is a circuit. For differentiator circuit, what is the difference? You see, here is resistor, here is capacitor. But in the differentiator circuit, the capacitor comes here, resistor comes there. That is the basic difference. So it is very simple. How can you transfer this one from this circuit to this one? Just select the capacitor, use this one, and then resistor, delete this one, and take capacitor at position here. Take 2 microfarad, and the resistor here. Take 5. Just run. This is the differentiator circuit output diagram. It's very simple and already those who know how to simulate in the Proteus, it is very easy for them. But don't just copy from your friend and others. I request you have to learn the software. As a CSE student, you have to learn a software, how to install, how to simulate. This is a basic things for a CSE student. If you avoid this and you just copy from your friend, it will harm in the future. Uh, in week two, I am not checking, but in week one, so many students are copying. But if same thing same happen again and again, I will go to the. I'm going to the strict point, and if necessary, I need to inform the proctor office. Those who copy from continuing copying, then university will take the necessary step. Maybe today's experiment is finished. And one thing again, I want to show you an sample lab report. So many students call me. What is the format of a lab report? How can we write the lab report? Please see this report. You see, this is a copper letter, and this is experiment name. No, this is experiment name. Then the theory with circuit diagram. Many students don't provide the circuit diagram. This is another circuit diagram by written in your own hand. Draw your own hand. And this is simulation diagram. You see, this is simulation diagram. This is another simulation diagram, and this is waveform of these two simulation diagram. This is a perfect report, and it is better to use A4 paper. Many students use the rough paper. Why? This is a lab report. If university will open, then you have to submit to and written in a A4 size paper. But why you avoid this in the online? Better you can use one page upper side and lower side of this page. It is better used in the online, but many of the students use the rough paper. It is sometimes the condition of the paper is so worse than I am thinking what are they are doing. They are not serious about in this course. But this is all about today. Uh, Thank you.